Hello everyone, my name is Bao. Today I'm going to tell you about the simplest math problem no one can solve.
This is the most dangerous problem in mathematics. One that young mathematicians
are warned.
Not to waste
their time. It's a simple conjecture that not even the world's best mathematician has able to solve. Paul Erdos, a famous mathematician, said mathematics is not yet ripe enough for such questions.
Here's how it works. Pick a number.
Any number.
Seven? Good choice. Okay, we're gonna apply
now we're going to apply two rules.
If the
number is odd, multiply by 3 and add 1.
3 times 7 is
So
21,
3 times
plus
7 is
22.
21 plus 1 is 22.
If
the number is even, we divide by 2.
So 22 divided by 2
is 11.
is 11. Now we keep
applying these two rules.
11 is odd. So
11 is odd, so we multiply by 3, 33, and add 1, 34, even. Divide by 2, 17 odd.
Multiply by 3,
51, add 1, 52, even. Divide by 2, 26, still even.
Divide by 2,
13 odd.
So we
Divide by,
add 1,
so we multiply by 3, 39, and 40. Divide by 2, 20, 10,
divide by 2, 5,
5,
odd.
Multiply by 3,
16, divide by 2,
2,
that's
8, and then 4, 2, and 1.
Now 1 is odd.
So we multiply by 3 and add 1, which equals 4. But 4 goes on, that's a loop.
So we're in a
loop. And the lowest number is 1.
Now the conjecture
is this.
Every positive
integer,
if you apply these rules,
will eventually end up in the 4, 2, 1 loop.
This is commonly called the Coles conjecture
after German mathematician Coles may come it up in the 1930s.
But the problem has many origin stories and many names. It's also known as the Ulam conjecture,
Kalutins problem, Weiss conjecture,
the Syracuse problem, and simply 3n plus 1.
Why is 3x plus 1
so famous?
Among professional mathematicians,
maybe it's not famous,
in the sense that if someone actually
admits in public that they're working on it, then there's something wrong with it.
The numbers you
get by applying 3x plus 1 are called hailstone numbers
because they
go up and down
like
hailstones in a thundercloud.
But eventually
they all fall down to 1.
Or at least
you think they do.
You can think of the numbers
as representing the height above the ground
so a number
in
like
meters.
26 would start 26
a number
meters
like
above
26
the ground.
will start
And if you
26
apply
meters
3x
from the
plus 1,
ground. We
it rises
apply
up as high as
3x plus 1, it rises up as 40,
in total,
and then it will
takes
take 10 steps to get to 1.
So 10 is called
So
its
10
total
is
stopping
called
time.
its total stopping
But
time.
take the very next
But
number,
take the
27,
very next number, 27,
and it bounces
bounces
around
all over the place.
In fact, it climbs
all the way up to
9,232
meters.
as an altitude.
At an altitude that's higher than Mount Everest.
Before it
also
too
falls
falls
back
to
to the
ground.
ground.
In total, it takes 111
takes
steps
111
to get
steps.
down to 1 and end up in the 4
Then
to
end up in
1
the 4 to
loop.
1 loop. Okay.
The paths that
The
different
fact that
numbers
different
take
numbers
vary
takes
so widely,
vary
even
so
numbers
widely.
right next to each other.
Even numbers
So
are right
how
next
do
to
you
each
even
other.
start to
So
make
how do you
progress
even
on this
start to make progress
Well,
on the
honestly,
problem? Well,
mathematicians
honestly,
struggled.
mathematicians
People
struggle.
just decided
People
this
just
was something
decided
invented by
that
the
this is
Soviets to
something
slow
invented
down
by the Soviets to slow
US
down human science.
and it was doing a good job at
And
it.
it was
because
doing a great job at it
everybody's
because
twiddling their
everyone's
thumbs and
sitting
no
there
progress
making
on
no
this
progress. This
thing
trivial
that you can
thing.
tell school
Yeah, you
children.
can tell school
Jeffrey
children.
Legarius is the world
Jeffrey
authority on
Legarius
3x plus 1.
is the world
The first
authority
time
on
I met
3x
him,
plus 1.
I was
First
a
time I
senior in
met him,
college,
I was a
and he
senior
pulled
in
me
college,
aside
and
and
he
he
pulled me aside, and he said,
"Don't do
this.
Don't work on this
Don't
problem.
work on this
you
problem.
want to have a career.
You want to have a career.
Do not start
Do
spending
not
time
spend that time writing
writing
about this.
about this or publishing any papers
Publishing
about
any
this.
papers about
Do
this.
real math
Do
for a
real
while
math for a while
to
to
establish
establish yourself.
Alex Kontorovich
Alex
didn't listen.
didn't
He
listen.
and Yakov
Yakov
Sinai looked at the paths of the hailstone numbers. Were there any patterns?
Were there
Well,
any
obviously,
patterns?
all of them end up at 1.
Them
But
end
what
as
about
1.
the paths
What about the paths
they
they take to get there?
The pattern
The
is
pattern
randomness.
is randomness.
Here is the sequence of a large number chosen at random.
A large number
The graph
chosen
peaks and then drops so low that you can't really see what's happening at this scale. But if you take the
you
logarithm,
take the logarithm,
you find this
wiggly
wiggly
graph with downward
It
trend.
looks kind of like the
Just
stock
like the
market on a bad day.
market on
And
a bad
this
day.
is no
And it's no
coincidence.
coincidence.
Both are
Both
examples
are
of
example of geometric
Brownian
Brownian
motion. That
motion.
means if you take
That
the log
means
and
you
remove
take
the
the log
linear
and
trend,
remove the linear trend, the
fluctuations
fluctuations are
It's
random.
like flipping a
It's
coin
like
each
flipping
step.
for
If
each
the
step,
coin
the
is
coin is
heads,
heads, the line goes up.
Tails, it
Tails
goes
goes
down.
down.
3x plus 1
Here's
is just
one
like the
like the random wiggles
of
of the stock market.
Over long enough periods,
Over
the
long
stock
enough
market
periods,
tends
the
to
stock
trend upwards, while
trend,
3x plus 1 trends down.
yes.
Another way to analyze 3x plus
Another
1
way
is
to
by
analyze
looking at
it
the leading
is
digit
by
of
looking
each
at the
number in
leading
a
digits of
sequence.
each number.
Here are the
sequence
hailstone
here,
numbers
the
starting with
hailstones
3
start
as
with
the seed. And we
whatever
can
the
count
heck.
up how many numbers start with a 1, how many start with a 2, how many start with a 3,
How many
and
start
so
with
on
3
to make
and
a
so on
histogram.
make a
We
histogram.
can do the same
So
thing
do
for the
that,
sequence that
you
starts
can
with 4,
sequence.
that's a short one,
For
and
short
for
one.
the sequences that start with 5, 6, and 7.
Okay.
Again, for each sequence, we're just counting up how many numbers start with each digit, 1 through 9,
Okay, finally got
and
9.
adding that to our histogram. If you keep
Yeah,
doing this
it'll just
for
go
more
on,
and
go
more
on.
numbers,
For more
eventually
numbers,
the histogram
eventually the
settles
histogram
into a
settles in
stable pattern. For the first
For the
billion
first
sequences,
billion sequences,
you'll find
you'll
one
find
is
out
by
that
far
what
the
is
most common
by
leading
far
digit.
the most
30%
common
of
digit.
all
30%
numbers
start with
1.
1.
Around
Around
17.5%
start with 2,
12%
start with 3,
and
and
the frequency
the
decreases
frequency
for higher
decreases
digits.
for higher
Fewer
digits.
than 5%
Fewer
of all
than
the
5
numbers
start with 9.
with 9. Now this pattern is
This
not
pattern is
unique
not
to
unique to
3x
3x
plus
plus
1.
1.
It actually comes
It
up
actually comes up
everywhere
everywhere
from the populations
from the population countries. Next one.